phosphoric acid, each proton dissociates in steps. You can think of it as, it's like each one has its own titration curve. Huh. Okay, yeah, loving that. So let's just look, first of all, at phosphoric acid. Phosphoric acid, when titrated with a strong base, will give you this. It has its own curve with its own equivalence point right there. Then, if you continue the titration, the next thing you're going to get is this. And it will have its own equivalence point. And so forth and so on. Okay, so this is the lab that we are now going to do after the AP exam. And it would have been really fun. And still will be. Because it's a triple titration.
How long does it take to
Not long.
there's not like one drop?
Well, what ends up happening is I'd like you to look at the pH changes here. You use a different color indicator. You use a different indicator at each go. So this would be the phenolphthalein. I think we use methyl orange for this one, and I have never done the third stage. We can now because we'll have lots of time. So the characteristics of this curve are exactly like the characteristics of a single curve. All right, you start out with a weak acid. You have a relatively flat part of the curve as you're adding NaOH. Halfway between the equivalence point is that special point on the graph where the pH is equal to the pKa. And then you consider, once you get to the equivalence point, a new titration occurring. Halfway to the equivalence, to the new equivalence point, you have the pH of the solution is now equal to the pKa2, and so on and so forth. Any questions? Okay, that's a little scary. Dead silence always makes me think of, wait.
I have a question about
Zoned out.
the halfway points. Would we ever have to find that when it doesn't just say at the halfway point?
Yes. Yes.
So like, would that be like?
They might say, give me, find the pH when you've added, and it will numerically be the pK equal to pKa, you know what I mean? They'll tell you that you'll have half as much base added as you do acid.
So it's always
And it would be very smart of you. I mean, if you did the math and worked out this problem, you'd come to the right answer, but boy, you can save yourself a lot of grief by recognizing it's halfway to the equivalence point. And you must do so. Okay, I'm not going to go through indicators. I would like you to read this, but on your own time. I will let you know that this is how you refer to an indicator, H indicator. The indicator is an anion. Okay.
Oh, that's not an actual.
No, that's an indicator.
I thought it was like natural log.
Yeah, it's indianic acid.
All
All right. Now that's acid-base titrations. Okay, you can turn it off.